Hey, YouTubers, Tazman here, bringing you another episode of Taz Teaches Java. And in our last episode, we went over a lot of scope and stuff. So in this episode, we're going to talk about operators. And operators are ways of manipulating data and comparing data. It's probably the two biggest things. And there's various types of operators. Now, we're going to go over at least, we're going to go over all of them pretty much, I believe. There will be some that we aren't going to pay as much attention to because they're not really used that often, or at least in what we're doing, they're not going to be used that often. And those are generally more along the lines of what are called bitwise operators or the shift operators. So we will kind of gloss over those, but we're not going to do too much with them because they're actually on the level of memory of 101110001 and doing that kind of stuff. So without further ado, let's begin. So the first type of operators we're going to learn, and maybe I should do this just so we can have a little example going as well. Let's go ahead and do a package. We'll call it OPERATO, or S, operators. And, oh, by the way, if anyone's interested, I can also publish this junk that we have here, that just kind of show you stuff. OPERATORS. Let me know if you're interested in that, and then I can probably get this up somewhere that you'll be able to download it. And operators. So here we have our new little operators class. And let's go ahead and hit tab and do a main. Now, I know I always do it this way, but it's very important that you learn the basic way, and the true way to do that is to do the public void. What is it? Public void. I can't. I haven't done it in a while, so I don't even remember. MAIN. Oh, I can't type today. Main. So it's the public, if I'm right, it's public static void main parenthesis. It's right here, public static void main string args. It's a good idea until you kind of really understand what this is, that you type it out. Once you've got it down pat, you can start just throwing it out. So the first type of operator we're going to talk about is called the unary operators. And these are, what that means is it doesn't need multiple arguments attached to it. It's just one. So it's like, I don't know, unary. It means one. And what they are is there's one that increments. It's the incrementor, and it's just plus plus. There's one called a decrementer that decrements things. There's one called not, and then this is kind of a bitwise one, but if you've watched my series on teaching programming logic, you would know what 2's complement is, and this is where you basically invert everything in that binary string. So if you had a 1010 and you applied this to it, it would be 0101. So it kind of does 2's complement, and that's just the tilde, like that. So these guys right here are your unary operators. And we're not going to go too much into the what was I just calling it? The bitwise complement is what this one's called. This one's the not, this is decrement, this is increment. So what they do is, for example, if we were to say S out, and once again, this is the shortcut where I just do S out and then do control space. But to type it, it's actually system with an uppercase S dot out dot println, and then parentheses, and then you can type your thing. So let's just say this is, with these guys, there's two types. There's the prefix and postfix. And prefix means before. Whoops, prefix. prefix means before, right? So this means the unary operator goes before what it's actually changing. So this is, you've seen this several times, but this would be like where we said, oh, maybe we'll have to go set up a couple variables here. Go int I equals 1 and a quote, well, not a quote, a semicolon. So then here, if we said print out I, like that, we could do I++, and this might do exactly what you expect it to do, or it might not. So if you're thinking that this will output I, which would be 1, and then it will increment it. Oops, let's go ahead and put that back. Whoop. Then let's just do another S out I again. And we'll just do I there, like that. So let's just run this real quick and see what it does. So, and we'll see if you're right about what you think it's going to do. So as you can see here, we did this and we output the I, and then we added to the I. So we're outputting first, then we're adding. So now you can see the prefix there, it says 1, and then we added to it, and then when we output I again, a second time, we get 2. Now, the opposite of that is if we prefix, actually that wasn't prefix, it was prefix before. If we output it here, then this is going to increment it, then it's going to output the I, then it's going to do that. So we're going to have 2 and 3 as our values here. Or 2 and 2, because we didn't increment it again. So we increment it here, and then we output it basically twice. So this is the increment operator. Now, this is the exact same thing as saying I equals I plus 1. This is just a quick way of writing it, because we're saying we have I, and we want to add 1 to it. So this will always only add 1, and the decrementer will always subtract 1. But where you put that double plus or the double minus is going to affect where, if I'm outputting it, like if I'm just doing a count and I just have the I++ or plus I, and then later on I'm outputting or using that value, either way that's going to be the same. But in this case, where it's in my output statement, you might not get the results you want if you do I++ instead of ++I. So hopefully that kind of made sense. Now if we do this, you'll actually see this one will turn to 3, because we're just doing it the long version right there. So we have 2 and 3. Okay, so these are our first ones. This one right here, increment. Oops, Control Z. And then this guy right here is D-E-C-R-E-M-E-N-T, decrement. And I'm not going to actually list this guy because we're not really going to use him much. But I want the ones that we are going to use periodically to actually be labeled here. So this last one is not. Now you can't do a not with, you know, with a value that actually has like a value that is not a Boolean. And if you remember, Booleans are true and false. So if we had here and we said, let's see, B-O-L-E-A-N, Boolean, and we'll just call it I am true, right? And we're going to set it to true. So if we output the value I am true, so if we do S out and say, whoops, I am true, here we're going to see that it's going to output true, right? So as you can see, it's true. If we use the not, it's going to invert it. It's going to turn anything true to false and vice versa, anything false to true. So if we say not I am true and say that, we get false. Now we cannot do that with this because it's not true or false. We can't say not I. I think we'll just get an error. And you can see it's already saying we have an error, and that error is that the operator not is undefined for the argument types int. So it can't be used on ints, chars, strings, and everything else. Has to be a boolean. So this guy is a liar. How about I lie? I lie, or whatever. No. So those are our basic unary operators. The next one we have is something you've probably learned in math class. And these are operators for manipulating data also, but we can do various things. And we have, basically, we have your addition, subtraction, multiplication, division. I'm trying to find the division. Whoops, the division. Oh, I know why it's doing that. We did a star, so it's moving it in. Oh, that's not division. Division. And the last one is called the modulus. And this is basically a remainder. So if, for example, I was going 3 divided by 2, basically I'm going to get 1.5, right? I think. 3 divided by 2. Yeah, I think so. We'll pretend that's right, even if it's not then. So an integer would say it's 1 because it can't do any decimals after that. However, if I want to know what the value of the remainder is, I'd use a modulus. So I'd go modulus. Well, let's just do this a little bit. So this is addition. We already know all these. T4zzTeaches. Subtraction. Multiplication, maybe you didn't know, maybe you did, but we use the little asterisk for that. Plication. Then this one, the slash, might not have known that one either. Maybe you did, but that's division. And then this one is probably the most likely you didn't know before. And that's modulus, if I spelled that right. So we already know what addition is. We could say I plus 5 equals, and it would output. You know, we could just say, we could say x equals I plus 5, or 1 plus 5, and that would add 1 and 5. Now the thing about the addition, when it's not considered an arithmetic operator, it's also used as a concatenator. So it concatenates strings. So you can say here is a string prefix plus I plus plus or plus plus I, and that's saying concatenate these two into one string. So it's converting basically our integer here into a giant string. So that's called the concatenation. So that's the other thing, and I don't think in my list I actually mentioned that anywhere else. So I'm going to do slash concan. I don't know how to spell this. Concant. I don't know. Concant. C-O-N-C-A-N-T. Concatenate. I apologize if I spelled that wrong, which it looks like I probably did because it wants me to. Let's mouse over and see if it. Disable spelling. Ignore concatenate. Yeah, I can't spell it. That's okay though. I don't have to know how to spell things in order to teach how programming works. So, all right, we do know addition, subtraction, multiplication, division. But let's go ahead and kind of focus on division, because division sometimes, like if we have int x comma y, actually let's do this, x equals 2 comma y equals 3. So if we have that, and then we say here, for example, we could say S out, and we could say 2 divided by 3. So this is going to show you what we were talking about. This is going to say 1, right? Actually, this is wrong. This is going to say 0 because we wanted 3 divided by 2. And actually, I didn't even want that. I wanted y here and x here. Wow, I'm doing great. Batting 100 here. So save that. So you'll see it says 1, but this is actually a decimal. Now, if we did this as a double, let's just change this to a double, we'll actually get the decimal value of it. So you can see 1.5, right? But we're going to leave that an int for now. So if, for example, we were trying to figure out, well, I only want the remainder of these two, I could actually change this and say SOUT. And then we could say, instead, we would say y modulus x. And this will give us the 5. Now, this is actually really handy for determining if a value is positive or is an even number or a negative number. And we'll probably go over that at some point. So as you can see here, now we have, oops, did I do that wrong? Y modulus x, or is it x modulus y? I shouldn't be getting a 1. Wait, is that right? Because this would be 0.5, so it would be 1 point, no, it'd be 1.5. So I think maybe I just need to change that. I'm not sure. 1.2. Hold on, I can't really dwell on this much, and we'll cover this in greater detail. But this is going to give us our modulus. If we said 2 goes into 3 one time. Oh, wait. And then it would be a remainder of 1. Okay, I'm not 100% sure. I'm drawing blanks on math today, so this is a really bad time to be doing this, I guess. Well, we're going to cover this a lot in some future programs, so I'm not going to dwell on it because we have a lot of problems to do. I wonder if I went maybe 5. 2 and then 1, because that means 2 goes in with a remainder of, I think it shouldn't be 5. I don't know. I could, no, I don't want to dwell on it. We'll cover this later, I promise. So let's not dwell on that right there. I think it's pretty simple and I'm just not thinking right or something. So that's okay. So moving on, we have the shift operators. Now this is one we're really not going to dwell on just because it is a bitwise operator. It's used for manipulating RAM, the memory at the 1, 0, at the very bit level. And there's the first one, which is called the shift left. Actually, I'm not going to name it because we wanted to name things that we use a lot. So just remember, this one is called shift left, and what it does is it takes your binary value. For example, if we had 0, 1, 1, 0, shift left would shift it, and then we'd have 1, 1, 0, 0. Then the opposite of that would be shift right, and then we have one called the unsigned shift right, which will shift them right and replace the end with a 0 or I can't talk. So it'll shift it right. So that's these shift ones. We're not going to dwell on those. Some more important ones that we're going to be dwelling on though. These, maybe I should do this and say these are shift operators. These are shift operators. These are arithmetic, M-E-T-I-C. I think that's it. No, that's arithmetic. Well, I'll just leave it arithmetic. And then these guys up here are our first ones. Let's go ahead and do that. And these are unary, U-N-A-R-Y, unary operators. I don't know why I put shift there. Operators at the end of it. The next one we have is called relational operators. Relational. I'm not going to put operator. And what they do is they compare things. So they check the relationship between two things. So like our unary means it only needs one thing. All these others, unless it's mentioned, need at least two. They need something on the left and something on the right. So for addition, we need our first number added by our second number. Division, same thing. You know, our the divisor and the numerator, whatever it's called. The relational, actually I think this is also kind of unary, but the relational operator is also a binary operator. It needs two. So you have things on the left and on the right that you're comparing. And with these, you probably know these from school and stuff, but we have the less than. We also have one called the less than equal to. We have the greater than, and we have the greater than equal to. We have the equal to. Now, one thing important to note is the equals, just a single equals, is an assignment operator. Right here, we're assigning the value true to I am true. Here we're assigning the value 1 to I. So one common mistake people will make when they're doing comparisons, they'll say, oh, if A equals B, and they'll put a single equals. Well, you're not doing a comparison. You're assigning the value in B to A at that point. So you need the double equals to be the equality operator, to check the equality between two things. And then we also have the last one here is the non-equality, or the not equal to. So this, once again, we learned up there, this is the not, this is not equal. And this might also be kind of a gotcha where you might think, oh, I have to do the double, but the computer knows that this is not trying to assign anything. So let's go ahead and label these guys real quick. I'm going to put some extra space on these because we have some that are 2. So we're going to do, this is less than. And the easy way to remember this is if you think of it as Pac-Man, and then he's got his mouth open up, he's going for the greater number. So the number here on the left is less than the number here on the right. Okay, so let's go ahead and do that guy right there. Control C. Do V. And this would be less than equal to. EQU, whoops, EQU-AL equal to. Then we can just do this, do paste again. This would be greater than, G-R-E-A-T-E-R, greater than, and then we'll just do copy U, Control C, and this one would be greater than equal to. And I don't think we really need an explanation for these. These are pretty common. Oops, greater than equal to. Then this is the equals, E-Q-U-A-L-S. And then the last one equals the not equals. So these are your relational. They check a relationship between the two values. All right, let's move on. Then we have our bitwise operators. Now these ones, like I said, we're not going to go into, but they are also kind of checking they're doing logical checks basically, and we've seen this I think in some of the programs we've written thus far, but we'll see the logical operators later on. So these are the and percent, saying two values, you know, this and this, and these would also be used in bitwise. I'm not going to talk about that actually, because that might be confusing and I don't want to confuse you. But we actually have our and. Maybe I should write these down just so you know them. So this one I said is the complementary, what I call it, the unary bitwise complement. Bitwise. Did I say complement? This is the bitwise complement. I think it's good just to label them. This is the shift left. Shift left. This one would be shift right. And then this one right here is, we called it the unsigned. Right. And then down here, so this is bitwise operators. B-I-T-W-I-S. Bitwise O-P-E-R-A-T-O-R-S. Or bitwise logic operators. And we have this one, which is the and. This one, which is called the or. And this is the, this or is also called, what's it called? Inclusive. So the inclusive or. And then this final one is called the exclusive or. And we're not going to go over necessarily what those mean, because like I said, these aren't that commonly used. The exclusive or. All right, so after that, we now have the logical operators. And this is, this we use a whole lot actually. Logical, O-P-E-R-A-T-O-R. Oh, I was going to say operators on each of them, was I? I only did on the ones we don't use. Okay, so these are our logical operators. And basically there's only two of these. There's and there's or. So as you can see, it's kind of the same one as, it uses the same as the bitwise one there with the inclusive and the and. And what these do is they compare your binary results. So if I'm using my relational operators and I'm saying like, is 2 plus 3 and 3 plus 2, if well, I don't know, maybe that's not, how about if 2 equals, or A equals 2, and we set A to 2, and then we say and B equals 3, and we set B to 3, then both those would evaluate as true, and a true and a true equals true. So two values have to be true in order for it to be true. Now the or is, it can be, the first can be true and the second false, or the first false, second true, or even the both can be true and it'll be true. So it's kind of an either and or kind of thing. And let's just do this. So let's say S out, and we'll just do 3 examples, I think. Let's do true and false. So this is true and false. As an and, it's going to return that this is false, because in order for it to be true, both these have to be true. So let's go and do that, and you'll see right here it's false. Maybe we'll do a couple more. Let's do s out, and then let's do true and, where's my and? Actually, let's do false and false. We already know true and true is going to work. F-A-L-S-E, and this should give us false as well. Oops, we have a misspelled false. F-A-L-S-E. So save that. And you'll see we actually get a false. So the only time and will be true is if both are true. Now it's not the same with our or. So if we say, oh, and I didn't type this, did I? Do and down here we'll do or. So let's go ahead and do a couple tests here. We have S-O-U-T. And if both of them are true, it's true. So we'll do S out there, and we'll do T-R-U-E or T-R-U-E. We'll do S out, and let's do a T-R-U-E or F-A-L-C. And I'm not going to do the opposite one of this, because if I do false and true, you know that's going to do it. But we will, just to show you that if we do have false and false, it's still considered false. So if I'm correct, we're going to see a true, and a false for the last three. There we go, a true, and a false. So this is your or operator. So you're comparing conditions. And let's see, we have two more operators still. So let's do, this is called the ternary operator. Actually, three more operators. Oh, actually, we do talk about the assignment operator. I just looked on my notes. So we have the ternary operator. Now, if we know unary is a single argument, binary is two arguments, we're comparing them or adding or manipulating, then a ternary is three, T-E-R-N-A-R-Y. So we have our ternary operator, which is three. And this is pretty much just a very exclusive thing, and it actually looks kind of like this. There's actually, the values actually go here in front of the question mark, and then here is, well, let's just say this is basically the same as an if statement. This is called a shorthand if statement or something like that. So we would say this. I don't want you to think that that minus is part of it. So we would say shorthand if statement, which is kind of funny because we haven't really learned about if statements yet. But if you think in life, you're always making these decisions whether a value is true or false. You know, you would say, for example, when I wake up, if it's Monday, I go to work. If it's Saturday, I go home. Or if it's a weekday, I go to work. If it's a weekend, I stay home. So let's just pretend, let's say day, let's do, how would I do this? Let's say is weekend, right? And we'll say equals false. It's not the weekend. Well, it really is the weekend. And we need to change it to Boolean. B-O-L-E-A-N. Boolean is weekend. So to check this, we don't have to actually type if. We say s out, and we could say is weekend. That's what we're checking, right? Is weekend. And then all we have to do is put the question mark, and we put what the value is if it's true. So if it is the weekend, then we say, let's say yes. And if it's not the weekend, so then we use the colon when we say it's not the weekend, and we say no. So here in this case, we're saying it is the weekend, or it is not the weekend, so this is going to output no, Stella. So as you can see, it's not the weekend. If we change this to true, that means is weekend being true, and this could be any condition you want. You could set the condition, but if we said true, and now we're happy. Yes, it is the weekend. Sweet. All right. The next one we're going to do real quick is the assignment operator. Is it two S's? ASIGNMEN, assignment operator. And this is what we were talking about. This is the equals sign. So get rid of U and say equals. Assignment operator. Because we didn't do that up in, yeah, this is it. So the assignment operator simply is what we use to assign something. We use it all the time in programming, all the time. I equals 1. I am true equals true. Down here, we used it here, boolean. Is weekend equals true. So that's the assignment operator. I don't think we really need to go into that one. Now this last one is kind of an odd one. And it's an instance operator. So let's go ahead and do boop and boop and boop. So this is called the instance operator, and it's definitely one of the more weird ones that we have here, because it actually is a word, INSTANCE, and it's instance of. And what this is, I guess I could just say it's instance of. It's checking if something is an instance of a class. So when we have our data types and classes and stuff, like for example, we have our operators class. If we created something, and we've done it in the past and we'll do it definitely in the future, so I don't know how exactly I need to explain this, but let's say, for example, we wanted to check if, let's say int, and we say, let's say int my letter, right? Why would we do this? I don't know. And we'll make it 23. So here we have an int named my letter, and we're assigning 23 to it, which kind of seems counterintuitive because 23 is not a letter. You would not expect that to be there. So what we can use the instance of is we could say my letter, INSTANCE, instance, oh, actually we need our S out first. S out, or our system out print line, and then we could say my letter, INSTANCE. I never used this one really, so instance of. So hopefully this works like I'm thinking, and we could say string. So I think that doesn't look like it's going to like an incompatible condition int and string. So I think it's giving us the error right there. I might have to do some investigation. I did see an example of this one. But like I said, I've never really used it much. But it can be very handy. From what I was reading about it, it can be handy. So I'll have to come back to this one and what the actual usage of it is, because clearly it's not this. But what the gist of it is you can check, for example, my letter here is an integer, and if we say instance of string, it's going to check if my letter is a string, or in this case, if instance of int. Did it like that at all? No, it still doesn't. Maybe I actually have to use the class one. Do I have to do it like that? Nope. I'm not sure. So we'll definitely have to look into this one. Because here we're getting insert dimensions of array type. Huh. We'll look into this one, like I said. But we are definitely over time. This is operators. We did get through all of them. I'm really getting excited because our next episode is probably going to actually be where we're making decisions and we're actually getting a program that does more than just prints out the word hello world to the thing and then ends. This is where we're going to be able to start giving intelligence, make our program seem intelligent, where we can have it say, how are you? Or, it can check the time on the clock and say good evening or good morning or good night, depending on the time of the clock, making it seem like it knows what time it really is. Even though it's really not an intelligence, it's looking at the clock and using our values to tell you what you want. So we're going to learn about what's called the if statements, or their conditional statements, and we're also going to learn about looping, which is really cool. So guys, I really hope you enjoyed this. We're going to go ahead and comment this guy out, and maybe I'll have a good example of this guy in the next episode. So like I said, thank you so much for watching. I really hope you learned something. Forgive me for some of the derpy things I did. I also am going to look into the logic behind my my modulus thing up here, because I know it's right, I'm just thinking wrong. So anyway, thanks for watching. Like I said, if you did enjoy it, be sure to leave a thumbs up down below. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my Discord and my other channels. And that's it. Until next time, I'll be seeing you later. Bye.